We present ProGesAR, a mobile AR tool for designers to prototype proxemic and gesture interactions of a subject in real environments from a third-person view. Designers can examine and test the prototyped interactions from both the first and third-person views. We conducted the interviews to distill the design considerations for our system. Based on the findings, we proposed ProGesAR. It supports 4 spatial-related events. ProGesAR allows designers to test and view the prototyped results from both the first-person view and the third-person view. To prototype a living scenario, first, the designer adds a Wi-Fi asset from the asset set to the AR scene and assigns a peer effect to the Wi-Fi asset. Then adds a bulb asset to the scene. Select a brightening effect and preview it, and then confirm it. Then add a music asset to the scene, and select a play effect to it. To add a location-independent event, the designer creates a square proxy and input a threshold value to specify a distance event. The designer clicks on the ground to specify a location-dependent event. The designer clicks the gesture button and selects sit to add the sit event. Clicks the orientation button and drags to rotate the red line indicating the facing orientation. Then the designer first selects the square proxy and the displayed event, then selects the Wi-Fi asset and the displayed effect appear. Similarly, the designer creates the mapping from the location plus orientation plus sit event to the play effect of the music asset and the brighten effect of the bulb asset. Switch to the test mode. In the first-person view testing, the designer holds the phone and walks approaching the sofa, and the Wi-Fi asset appears. Then when she sits down on the sofa with facing forward and press the sit button, the music is played and the bulb is brightened. In the third-person view testing, she asks another test subject to come to the AR view and perform interactions. Besides the predefined assets, users can import their prepared assets from the album. To evaluate our system, we conducted a preliminary usage study. We first let users reproduce a representative scene for the training session, and then conducted an open-ended study. Here are some prototyping results. When the test subject approaches the desk, a light brightening effect is triggered. When she sits down on the chair and faces forward, a wind shaking effect is triggered. This is the result from the third-person view. This is a result that when a test subject comes to the drinking fountain, the water temperature will appear on it. When the test subject pointed out, the water flow will appear. This is the result from the third-person view. When the test subject passes by a table, a mask sign shakes on the table, and the music is played to remind the subject wearing the mask. When he comes to the door, an arrow appears to remind him to test the temperature. This is the result from the third-person view. When the test subject approaches a sitting area, a prohibition sign will appear to indicate the 2 chairs cannot be seated. This is the result from the third-person view. So the subject sits on the middle chair. When the test subject approaches the cook, it displays a shaking fire sign. When he comes to another spot, a check mark appears. This is the result from the third-person view. Here are more results involving the events of location, orientation, distance, and gesture. Users can easily and quickly prototype their design ideas about proxemic and gestural interactions using ProGesAR.